Go ahead.
Before we start, how experienced are the students? Is there anything I should like skip over or explain in more depth? I'm gonna go a lot in depth on like containers and also AWS.
I would not assume that they have any familiarity with that stuff at all. Some of them do, but probably some of them don't. So you should, start from the bottom.
Okay, this talk is very much oriented towards people who understand a little bit of that, so I'll try to go a little bit slowly. That said, there are 90 slides. So we'll see how far we get through. Okay. Start the screen share. Okay. Can you all see this?
Yep.
Great. So my name is Kaz. As you know, I was a student here and I work for Amazon on the devices and services red team. So my job is basically to do pen tests, but they're sort of objective oriented instead of wide scoped. So my team goes after specific objectives. So for instance, like gaining access to all of the data from Alexa might be a good example. Like we would explore the question of, can we do that? Is it possible? Let's figure out how to do that. And in this talk, we're going to be talking about Kubernetes. This talk is meant to sort of like be an introduction to Kubernetes, but specifically focused on all the things you need to know just to sort of like be competent enough to understand what's going on. It's not focused on building things, but more focused on like hacking things. So what are all the things that you need to know to hack a Kubernetes cluster? We're also going to be focusing specifically on EKS, which is Amazon's AWS managed version of Kubernetes. So there'll be a lot of focus on that specifically because that's what I work with a lot of the time, but it won't be explicitly focused around that. So we'll start with talking about like why it's important, why you should care about it, especially as students. I think it's a great thing for you guys to learn right now. We'll go through building a sample app, and then we'll go through some real world exploitation exercises of sort of like what are attacks that work, and we'll go through a lot of default misconfigurations and insecurities in Kubernetes and EKS. And lastly, we'll talk about how to harden it a little bit. So the first thing is why. I have had to cut some data out here, but I think there's a lot of really interesting stats. One of the things I got to talk to with the EKS team about was like how much of all EC2 usage, which is like all of the servers that you would run on AWS, is Kubernetes. And a solid 25%, I think, was roughly that number, is slightly more than that, is actually EC2 servers that are running as part of Kubernetes clusters. And so a Kubernetes cluster is basically just like a very large amount of servers that are working together in order to orchestrate containers. So like small copies of applications in order to scale services dynamically. And it's mostly how services are built now. A couple of these stats here, these pie charts are from a Red Hat survey. 67% of industry leaders have slowed down deployment into production of applications due to Kubernetes security concerns, which I think is interesting on its own. But I think what it says really is that not a lot of people really truly understand Kubernetes security, and it's like very complex. And it's very much a niche sort of thing to know. It's not your sort of classic web application security or exploitation, like building exploits. So I think it's very, very helpful and a good thing to get into right now. Lastly, it's like a massively growing project. I wouldn't say it's growing anymore. I guess it's just very fast paced, thousands of contributors. I think when I had just like looked at the GitHub, there was a commit 29 minutes after I had, before I had just looked at it. So super active, very important right now, very relevant. My sources. And I think we're gonna get right into building a sample app. So this is a little basic app that I built. I think I stole the code from just some example of building a Django application, just like a basic Python web server. And we're going to go through all the things it would take to turn a really basic application like this into something that you could run on a cluster. So the application itself looks like this. It's not very complex. There's just sort of some files that are standard for Django applications. If you went into the polls section, you can see the source code. I haven't really modified anything here from the sample application. The only thing I've added is a Docker file and a few different things I had to change in order to get it running. And the application itself actually doesn't really need to change in order to put this application on Kubernetes and host it as like a scaled service. So what does change? Well, these things. So basically, you don't need to modify the application code at all, but you are going to need to have a lot of infrastructure as code that determines how it's deployed and the objects that exist on the Kubernetes cluster. So if you start looking at these, they're not going to make a lot of sense. You're just going to look at this and it doesn't really contain any values. So there's really nothing for you to read or parse, like, especially if you are unfamiliar with what everything is. Well, you're like, well, what is it? You know, there's really nothing there. So simple. It's just this. I apologize for this. It's kind of like getting flashbanged by a diagram. These are all the things that you sort of need to know about in order just to like build an application on top of Kubernetes. And this is really like why it's complex. If you start like reading this diagram, you probably aren't going to recognize any of the things actually on the diagram. And that's because none of them are strictly real. These are all concepts invented by Kubernetes. Everything is an abstraction. So basically, all of those things back here represent real things. They represent like real EC2 instances, like I was talking about earlier, and real disks and load balancers and all the stuff you would normally see in an application environment. But they're represented in different ways. And so let's unmask these guys. It's actually really simple. I think as long as you drill these things back down to what they actually represent, it's not so complex. And I think that's really the secret to starting to understand these things. Kubernetes itself is a container orchestration platform, right? And that means a lot of things. But basically its whole job is to take Docker containers and then scale them out to meet some amount of load or something of that nature. Some batch jobs or some network traffic, just to make sure that your applications are highly available. And so a pod is basically just a container. It can be multiple containers. It can get a lot more complex than that, but basically it represents a single instance of an application. And then there's all these other sort of areas here, right? Like these auto-scaling groups are basically just what a deployment or a horizontal pod autoscaler might be. These are all sort of attributes or functions of something that's real, and that thing that's real is an auto-scaling group. In AWS, an auto-scaling group is sort of an image with a specific set of settings for a server that you might deploy. And then there's a number which determines how many of those things you want to run. So what Kubernetes is going to do is it's going to have some metric that horizontal pod autoscaler is going to use to determine what the number of servers should be. And then a deployment is just the thing that's running on top of that auto-scaling group, right? And these are just different ways to sort of group those concepts without having to deal with the actual infrastructure beneath it. So storage, there's persistent volumes and storage classes, and these are really just disks. EBS is basically just a network attached storage disk in AWS. EFS is like an NFS share that you can attach as a disk. And these are going to be the things that actually represent these volumes and storage classes and etc. And then as far as like the network goes, these are all sort of different kinds of objects that you can create in Kubernetes, like a network policy, which is sort of like a firewall rule. And then there's endpoints and services and ingresses, which more or less represent a load balancer, something that would stand in front of an application and then serve traffic to it and maybe define some metrics that defines how your pod scales. This section here is almost entirely new. There are some tie-ins to real things and in the IAM and sort of security aspect of Kubernetes, but there is also a lot of new stuff that's implemented by Kubernetes itself, which doesn't actually represent anything necessarily real. And lastly, there's configurations, and these are just stored in a database. And the database is etcd, it's a key value store. So if you've used Python at all, it's like a dictionary. Basically, the server is just looking up a key and retrieving a value, and that's all a secret in a config map. Or a secret is just a config map or a value that has some amount of restrictions on it. So that was a lot. I wouldn't blame you if you didn't get all that. And here's an even simpler view. We have lots of pods that run on top of servers, and the servers are represented as nodes, right? So it's pods and nodes, and then a node is really just anything that runs containers or pods on top of it. And it has a couple of services called kubelet and kubeproxy that are important to actually make this work. And then all of those nodes are basically just specific servers that call back to some master node that controls everything. And this has the application that is actually Kubernetes. But really drilling down to it, all it is just a large group of servers that run Docker containers on top of them. And then a bunch of other abstractions to help you define the surrounding infrastructure. All right, cool. So the last thing we need to understand before we can really get into the meat of it is Helm charts. And Helm charts are super cool because they allow us to deploy whole stacks really, really easily. So as opposed to Docker, how you can just sort of like deploy an entire application from a container, a Helm chart allows you to deploy multiple entire applications or even other infrastructure components based off of a chart, which is sort of like a template list, and that's what we saw earlier. And this is really helpful because as opposed to something like Terraform, which stores state in its own backend or locally, this is all stored on the cluster's config map. So the state is stored so that anyone on the cluster can access it, and it sort of knows what its own state is. Cool. So all we've done here is we have defined a Helm chart, and this is a values file. This includes all the values that you'd want to template or change between deployments for Helm charts. So all those values that we saw earlier that were missing are actually defined here in like a values.yaml file. This is what a values.yaml file would normally look like. This is a reverse proxy here using Nginx, a very, very standard configuration for it. Just exposing my application, my service on port 80 using Nginx, which is going to get spun up by a plugin, which we'll talk about later, and point at our application deployment. And so this is what it looks like when it's templated out, right? It's basically the same thing, only you need to pull the values from the values.yaml file. Cool. So we're gonna skip over this section. I don't know if we have time to deploy it and go through some live demos. So we're gonna skip straight into hacking it. So going into this, you might ask, like, how can I hack Kubernetes, right? How can I hack EKS? What am I actually interested in as an attacker? If I land on something and hack the box and I don't know what to do, like, what do I care about? Well, what would you normally care about? Remember that each of these things is actually just an EC2 instance or a cloud instance. And you can do all the same things that you could normally do on an EC2 instance, which means that you could, play around inside the file system that you have access to. And then you could also access IMDS, which is the instance metadata service. This is a really classic attack because it normally will allow you to gain access to a role if the EC2 instance has one configured, which then has permissions within somebody's AWS account. And then so classically, you typically want to figure out like what permissions you have on that role, and then try to abuse those in order to escalate your privileges and gain additional privileges. There we go. Cool. So what do you have? It turns out you have a lot of things by default. In fact, you don't even need to do enumeration. Normally, you will need to do enumeration. That's kind of noisy. You need to figure out like, okay, I need to try each action, figure out what actions I have. But because we're using EKS, all of the nodes have a specific amount of actions they need to be able to do in order to function. And it turns out that these are misconfigured by default. So one of the things we can do is we can list all of the instances in the account. This is going to be the exact same policy on any EKS that you come across, unless they've specifically modified it, which is sort of rare and unlikely. You're going to be able to list all of the instances in the account, no matter if it's within the same virtual private cloud or VPC or not. You're going to be able to look at the route tables, the security groups. That means you can inspect the firewalls. You can also see the subnets and the volumes attached to all those instances, and everything else within the cluster as well. So we'll use that in a bit. So that's going to be very, very helpful. So once you get an initial foothold, you can just gain access to a bunch of things really, really easily. So there's also this, oh, I think I skipped a slide here. I did not. Okay. So there's also the VPC CNI policy. And this is really interesting because in addition, this one is going to allow us to not only look at networking information across the entire account, that's what this resource star means, but it's also going to allow us to modify things. There's this really great write-up by a company called Eltum, where they were able to use this in order to detach a network interface, what you would think of as like a network card, right, from a server, and move it to another instance. And that's really interesting because a security group isn't actually applied to a specific server, or a firewall isn't applied to a specific server, like you think they are. They're actually applied to the network interface. And because they're attached to the network interface, that means that you can functionally take a less restrictive firewall, or maybe a public IP address, or a network interface with a public IP address, and you can add it to something that the developers of the application never thought should be exposed or never intended to expose. So if there's locally running services that might be sensitive, which is quite common, then you can potentially gain access to those things. And the really interesting thing about this is, I got the screenshot straight from the documentation, is it's not usually desirable that pods running on the node inherit these privileges. They know this is a problem, this is how it is, and they've just accepted this fact because you can't change these policies once they've been created, and they didn't have other ways to deal with these things when EKS was first created. So a lot of these things are just still running on these old policies. Could they fix it? Absolutely. Have they done it? Not yet. Okay. And I wanted to see, yes, I skipped this one. The last thing that you're going to get by default is all of these ECR privileges. And this is going to be huge because this actually allows us to read the source code of all of the applications that are deployed on the cluster. That is, if they're using ECR, which most developers are going to. That's I think it's Elastic Code Repository. I'm not sure exactly what it stands for. But basically, the nodes need to have access to this in order to get the images they're then going to run within the cluster. So therefore, anyone who has access to the node's IAM role can also download these images, which are just Docker images, and then read the source code, no matter if it's the one that you're running on or not. This is really great also for finding secrets. I think if you go online and play with KubeGoat after this, or the Kubernetes Goat, highly recommend it. They have a scenario about this, and it's a good thing to go through. And so these are just all the things that you have by default. These are things that you're basically guaranteed if you land on a box that's running on EKS. So let's see how we can sort of like leverage those things. Let's go into a live demo here. Actually, hold on.
Okay, while you're setting up, let me just put something in the chat so they know how to get their points.
Cool.
I have to get in Twitch for just a minute. All right, this is fantastic, by the way. Carry on.
Cool. Yeah. So we're going into a live demo here. What we're going to do is we're going to show you how basically to sort of get a grip on like what's running. So we can use this tool called kubectl. This is basically how you're going to interact with it. I think Kubernetes can seem, again, really complex before you actually start like playing with it and understand what everything is. kubectl, I think, is helpful for getting rid of those abstractions. We can see that this isn't actually so complex. There's basically 2 containers running on our cluster right now that we need to care about. And we have important app and Ubuntu. For this example,
We're only seeing the slides. Are we supposed to be seeing another desktop?
Oh, yes, you are supposed to be seeing a desktop.
All right.
Let me go ahead and change that.
Yeah.
Oh, were you seeing my presenter view the whole time?
Yeah.
Yep.
Oh, that was not at all what I intended to be showing.
Yeah. Well, yeah.
All right.
It was good to see your notes.
Yeah. Yeah.
Cool.
I didn't mind at all.
I'm sure you didn't.
Now,
Okay,
a terminal with little tiny letters.
right. Should I bump that up a little bit?
Yeah, that would be good.
All right. Cool. Is this good enough? I think
Yeah,
this is as it gets.
that's pretty good.
All right. Live demos, everyone. So we're going to go ahead and basically exec into it. If you've ever used Docker before, Kubernetes is the same way. It's designed to work very similarly to Docker CLI. So we can just do kubectl exec, Ubuntu, and then we can basically just SSH into a running container this way. So we're going to execute bin bash, and now we're on the container. So let's do describe instances. And basically what we're doing here is we're using the AWS CLI to try and describe the instances. And you can see here that by default, we don't have this right now, but if we go ahead and we need to unset a specific variable. Let me pull that up. And I'll show you why that is in a moment. Let's go ahead and do env. We're going to go ahead and unset this. Cool. So what just happened? We actually had a AWS role by default, and that was defined in our environment variables. So the AWS CLI was looking at this web identity token file and reading our token and using that to authenticate to AWS APIs, specifically the EC2 describe instances. The role that we had access to did not have access to describe instances. But now when we unset it, what happens is our AWS CLI is going to go ahead and get our permissions from the instance metadata service, which is what I referred to earlier, which is going to grant us the default node role. And that's the interesting thing, is that these pods all have access to the node role by default. So we're going to be able to get this every time. So now when we do describe instances, we can start to look at all of the instances running across the account. We can see they have some client tokens. We can see their hypervisor information, their network interfaces, the public IP address, security group information, a lot of really good stuff. And we can basically do this for any of the other APIs that I showed earlier. And we can also do this to, say, describe security groups. So I do this. We can start to look at all of the security groups on my account. And so we can see that there's this one, which is managed by Terraform, which is opening up port 80 to the internet. And we can also see that I have a few rules here for my nodes. So this one is allowing all of the nodes to talk to each other. And you can see that just public IP address space or private IP address spaces are allowed to talk internally over SSH. And we could go through and we could look at all of those things as well, which would be really useful to an attacker. So going back to the slides, this is how it's supposed to look. We could go through and modify network interfaces. We're not going to get into that today. So the caveats to these things are that you can't create new security groups. So you can't just arbitrarily create new firewalls. It's not like you just have access to completely change everything. You have to be really crafty about it. There's a lot of rules that you sort of have to adhere to when you're messing with these things. But as far as like read access goes, you can do pretty much whatever you want. Cool. So let's get into internal services. Kubernetes also has an internal DNS service. Another reason that's kind of complex. So it runs its own DNS server that all of these pods are going to hit, and that's how all of the internal services know where to look for each other. So how do the applications that are actually running on it know where those things are? Well, they can follow either this pattern, the service namespace, and they can do a DNS lookup, or they can look for just environment variables. As an attacker, again, super useful to us because now we can enumerate all of the other services that are within the environment. So if I look here, you can see we have the Kubernetes service host. That's going to be the master node's Kubernetes API, right? That's what we're actually talking to when we're making like API requests against Kubernetes to see all the pods, for example, or to exec into a pod. That's the IP address that the node would talk to. And then we can see there's also this pull service port, which is 80. And then we can see a few other things around here as well. An interesting thing to know about this is that it's only going to inject these things for all the services that are in the same namespace. So because polls is the only service within the default namespace, that's all you're going to see. We'll talk about namespaces more later as well. We also won't get too much more into the networking because it can get pretty complex. This is sort of what it looks like. It's basically a bunch of pods running on the nodes, as you can see here, right? And they have virtual Ethernet adapters, which go into bridges, which is basically going to talk to IP tables before hitting the cluster network. And it's going to do some interesting sort of traffic shaping IP like natting to translate things before it actually hits the cluster network in the outside world. Cool. So we already did the environment. We can do a dig on polls default service cluster.local quick. Is it poll? Yeah, polls.default service.cluster.local. Okay, we don't have dig installed. Do we have host? And that's the other thing about these containers is that they're very minimal images. They almost always will have no standard utilities on them. Was that Sam?
I just wondered if they had NS lookup.
Let's see.
Oh,
Nope. No NS lookup. We might not even have like ifconfig. Okay, we do have ifconfig, but I've installed a lot of things. I've added a lot of things onto this Docker image. Normal container images, like Alpine, for instance, are like in the single or double digit megabytes. They're really, really small. And they're going to contain like not even Vi, not even Nano, no text editors. There's nothing. So you pretty much have to be running your application code, and that's all they're built to do. So there's a lot of things as an attacker that are going to be like more difficult, even just because you're using a container image. Cool. So next thing was we're going to get into the authorization flow. So we've looked at our AWS role a little bit. We sort of know what we have access to by default. What do we have access to within the cluster? So the service account is basically how each node is going to authenticate to the API, or how individual applications are going to authenticate to the API. And again, Kubernetes has to provide these things into the applications at runtime. So it has to live somewhere. And where it lives is here. var run secrets, Kubernetes IO, and / service account. And this is where most of the secrets are going to get mounted into one of the applications at runtime. So if we go ahead and we do like an LSLA, we can see that there's a few different items that we've got mounted into our instance already. We have a token, a namespace, and we have a certificate that we can look at. And this is going to be really useful to us in order to actually talk to the API. We can also go back to our environment variables. And our environment variables are where we can see usually our service account as well. Let's see if we have one in here. I'm not seeing one immediately. That's fine. So we can go ahead and we can start to try and use like kubectl in order to talk to use the token that we already have. And I've already gone through the difficulty of installing kubectl on these instances, but normally you wouldn't really have kubectl. So we're going to go ahead and use kubectl, and we're going to see that by default we can access some things, and that's because we have a service account. So we can do like kubectl get pods, for instance, right? And we can see our service account has access to get pods. That's great. And we can then use that in order to access the API, and we can sort of do the enumeration that we were talking about earlier as well. So let's go back to service accounts, and we'll explore permissions more in a moment. So the way that these things work are that service accounts have a role that is granted to them. This is a sort of standard role-based access control. It's a bit complicated. There's also attribute-based access control in Kubernetes. But most of the time it's going to look like this. you have a role which grants access to a specific set of verbs or like actions that you can take on a resource for a specific API group. And an API group is like a you can think of it like a different service, right? Like the default service, or maybe we would have something that's like networking, and it would have a different set of resources and verbs to go with it. And then what we're going to do is we're going to take those roles and we're going to attach those roles to users or service accounts via role bindings. And a role binding is sort of the glue that just connects these two things. A role doesn't specify a service account or a user by itself. You can't do that. You have to have a role binding. And a role binding will specify the user that gains access to that role. Now, lastly, there's namespaces as well. So again, we only saw those two containers, right? But that's because all we're looking at is the default namespace. There are, in fact, many namespaces that exist within Kubernetes, and you're not going to see all the things that are running if you don't know about them. Namespaces also sort of act as trust boundaries for certain things. So if I do kubectl get pods-a, that's going to be all namespaces. And we can see now that we have a few different namespaces. Kube system is basically the system 32 of Kubernetes. This is where all the stuff that makes your cluster run will live. And all of these services are really important services. Remember I talked about the DNS earlier? That's right here. You can just go ahead and look at the core DNS instance, and you can exec into it if you wanted to. And you can inspect all of the variables that it's using to run with, and all of those sorts of things, because we have access to that right now. Now, because there are namespaces, these are a trust boundary specifically for roles and role bindings. And you can combine them in different ways. You can create a cluster role, which can take actions on any namespace rather than a specific namespace, or a cluster role binding, which can apply to subjects in any namespace. And you can combine these interchangeably, right? So that you can create any sort of role-based access control scheme that you would really want to do. But again, namespaces are not boundaries for everything. Apparently, a lot of people will assume that just because something is in a namespace means it can't talk to things in other namespaces. That's not true. The network segmentation is non-existent by default. It's flat. So just because you can't see these other services running doesn't mean you can't talk to them. A good example was the DNS service that we saw earlier. Everything in the cluster needs to be able to talk to the DNS service. And so the DNS service has to be accessible to other namespaces. So putting it all together, this is sort of what it looks like. You can have cluster roles, cluster role bindings, roles, role bindings, and you grant those things to service accounts, and then pods gain those service accounts. Now, if a pod has that service account, what it means is it has a JWT or some access token that it can use to authenticate to the API for that identity. Cool. So now that we know all of that, we sort of know how the authorization flow works. We can start to enumerate what service accounts exist in our cluster and what we have access to. So let's see if we actually have access to list all the service accounts. Normally, what you can do is you can just do get and then the name of the resource type. So how I did get pods earlier, I can just do get service accounts. But my user doesn't actually have access to list the service accounts. That is unfortunate. An interesting thing is that we will show you what the service accounts are in a moment. But just because we can't list the service accounts doesn't mean that we can't actually get them all. And the way that we can do that is we can do like a get command on, per se, one of the pods. Because we have privileges over the pods, we can get the service accounts because they're part of the pod's configuration. So I can say, I can get pod Ubuntu, right? And that filters us down to just Ubuntu. And then we can get the output in YAML, which is the raw format. This is what it really looks like on the back end, not the human readable version. And we can see all of the things about how this pod is defined. So we can actually see that we have the Ubuntu service account on our annotation. And we can go ahead and we can look at the labels. We can see the command that's running. So this is just an Ubuntu instance that's running sleep for a really, really long amount of time. And we can also see the name of the role that we gained access to. And if we went to, if we wanted to just like list all of them without filtering anything out, we could get all of the service account names, by just doing get pod OYAML for all namespaces. And now we're looking at the configuration for every single pod in our cluster, and then we can infer a lot of information about everything else that way. So just because we're able to get pod information, we can actually gain a lot more information than you might expect. Okay, yeah. So then we can also look at role bindings and roles through the same sort of process. Describe is just get, but it sort of includes more details, like what you saw in the YAML, but in a more human readable format. So for instance, we have our service account, which is Ubuntu service account. We can do /kubectl. We'll do it from outside of our cluster, because our specific permissions right now don't grant us this access. So we'll do kubectl, describe, service account, Ubuntu service account. It'll take a moment, and we can see that it comes back. We can actually see the annotations on it. And there's not a lot of interesting things for us here. We could then sort of like do the same thing with roles or role bindings or anything like that. And it would tell us the permissions associated with those things. So next we're going to go into the actual really fun part of the talk, which is actual exploitation for load escalation. This is going to be another sort of default attack that you can do. This actually it works on GKE as well. Not just EKS, and I think it also works on DigitalOcean last I checked. It works a little bit different on different providers, but this is basically due to the node bootstrapping process. When you're joining a node into a cluster, you have to be a little bit careful about this. Normally you'd say, oh, like, well, if someone's joining their server into my cluster, that's great because that's like free compute for me, right? Well, not so, because you don't actually control that compute, right? If you start scheduling applications on a node that somebody else controls, then the applications are then also under their control. And so in order to join something into the cluster, there's a specific process that has to be followed. With a vanilla Kubernetes installation, it's going to look something like this, where kubelet, the process that sort of manages the node, is going to gain access through an auth token and credentials. That's given like a bootstrap token. Usually these are valid for like 2 hours. And then it's going to perform a certificate signing request. It's going to say, hey, I generated this certificate. Can you sign this to the kube controller manager? The kube controller manager will sign it. They'll say, yeah, you've got a valid account for 2 hours right now, and it proves who you are. And then they have a signed certificate, which they can use forever after to prove their identity to the cluster, right? However, this works very, very differently on these managed environments. And we're going to be using a tool called kubeletmein in order to gain access to a node role, because the nodes have to have their own specific role. So like how we were able to do a few different things with the API here, we're going to be able to gain access to a little bit more through this tool called kubeletmein. And then we'll also talk about how it works. It's really not a very complicated tool. You can do it all yourself with curl if you wanted to. So we're going to go ahead and copy the command out of my notes. So what this is going to do is this tool specifically is used for gaining access to a node service account. We're going to run kubeletmein EKS, and then we're just going to overwrite one of the strings because it's incorrect in the implementation. And we're going to be generating a kubeconfig file. And a kubeconfig file is the configuration that is going to allow us to authenticate to the cluster. So let's go ahead and write out that file. Cool. So we can see that it was able to parse the user data for the instance and then generate a kubeconfig file. So let's go ahead and cat that file and see what it looks like. So here's what it looks like. We have some certificate authority data. Remember how earlier we saw a certificate when we were looking at the service account details that were injected in the secrets directory. This is important to be able to talk to the cluster. It basically proves the cluster's identity and is important for authenticating to it. And then we also have the location of the server. So we can see this server actually is publicly accessible. There's a domain generated by EKS for us, and we're able to get this information through describing the cluster, which we have access to do with our default IAM role. And then we can see how it actually gets the creds. There's no token, there's no actual secret. All it's doing is it's running this AWS CLI command. It's running the command AWS EKS get token for the cluster name EKS for hackers on the region EUS1. Region actually doesn't matter. It'll still give you the token anyway. And we can use this file to authenticate as the node. So let's go ahead and demo what we can get access to through this. Let's go ahead and go with this part for now. Node permissions give you a lot more than what we had previously. Previously, we basically just had list and get on pods, which was not a lot. But through node permissions, because they need to be able to list and get the pods, we can do those things as well. But there's also a lot of sort of special permissions that we can do. One of those things is get secrets, because a node needs to be able to get a secret in order to inject it into a pod. This is going to allow us to read sensitive information for anything that is scheduled on the same node as us. This is super useful because say that we, are running on a very small cluster like we are now. I think this cluster right now is running on only a single EC2 instance. And that means that all those things that we saw in Cube system earlier are also likely running on the same node as us. And then we can get all the secrets that those things have, and we can pretend to be those services and access those things those things can do. This is going to allow us to escalate privileges in the environment or do things that we really shouldn't be able to do. We're also going to be able to like list nodes and do a bunch of other recon around the environment. So let's go ahead and do that. So let's go ahead and we can get pods just to see if it works. You can see that it does work. And then we can go ahead and we can do get nodes, for example. And this is something that we can't do. Let me just prove that real quick. Without this without this node token or service account. So we can see that there is actually only one node joined into the cluster, which is really helpful. That means that everything that we see running on the cluster is going to be running on us, and we can access their secrets and that sort of thing. So let's go ahead and determine, I'll show you like how you could determine what's running on the same node as you if you didn't know. You can do -o wide, or you can look at the properties of each specific pod. And this is going to tell you exactly what node each of these things is running on. So we can do this across all of the namespaces. And we can see that the node is in fact the same for every single pod running on the cluster. So these are all running on the exact same server, even though they're all a bunch of different applications. Cool. And so we can get that data ourselves. And this is something that I would encourage you to do as well. When you're using tools, always figure out or try to figure out how they work. Because a lot of the times it's really not magic, and you're going to level up a lot by figuring it out. So here, all we're going to be doing is we're going to be authenticating, or we're going to be grabbing a token from the IMDS v2 endpoint. Now, normally what you have to do is just hit an endpoint with IMDS v1, and there's no authentication. It'll just let you have all the information, all the secrets that you need in order to get a role. However, with newer IMDS v2, it basically makes you have a secret. You can get that secret through querying this API yourself. It's really protection against server-side request forgery. I'm not going to explain that now. I think that's beyond the scope of the talk. But we can then go ahead and we can use that token, for example, with this curl request. You can see that we just curled the IMDS IP address, and we grabbed the user data, and we set a header that was containing our secret that we have to use in order to get access to it. And we can see this script. So this is what's going to run, the user data script is going to run on every EC2 instance when I start up. It's going to pull this, and this is how the node figures out who it is. So we got the information about the cluster itself. We saw this earlier in the kubeconfig, and we also see that's running this bootstrap script. That bootstrap script is what's going to reach out to the endpoint and grab its token and then authenticate into the cluster. But that's really all it is. And we can actually go ahead and we can look at the bootstrap script because most of this is open source. And we can see all the things that are there. I won't be doing that right now, but I would encourage you to. Cool. So we can reset that. We're going to do that currently. And so now that we have this node service count, we can use this to do a lot of really interesting things. So we did this earlier where we showed all the pods and we figured out, all the stuff that's running on our same node. But we can also use this to steal secrets. And we can do that by the technique I showed you earlier, where we can see the entire configuration. And even though we can't actually list all the secrets, because we don't have access to do that, if we do like kubectl, kubeconfig, and then we do get secrets, for example, we get forbidden, right? But we can see the names of those secrets, and then we can pull them if we know that they're running on the same node. So let's go ahead and do a quick demo of that as well. Let's get the pods. And then we can see there's this important app that's running as well, right? So let's go ahead and see if that one has any secrets. So we'll do a get pod for important app. And then we're going to put that in YAML. And then here we can see there's a secret password for important app. And there's a secret key reference that's defined in its configuration. And the name of that is admin creds. And so we can go ahead and we can try and pull that specific secret because it's running on the same node as us. So that's just going to be what you saw earlier. You guessed it, kubectl get secret, and then the name of the creds for the secret itself. Cool. So now we've proven that we've actually been able to get the secret. We can see the password here is a bunch of random characters and a random username as well. So if we were a real attacker, we could probably use this to authenticate to that important app or do something that we shouldn't be able to do. And we'll be taking this a little bit further in a moment. So because we can get secrets, we can also get other service accounts, which is going to allow us to do a lot of really good stuff across the cluster. So for instance, here, this demo is looking at this application called K8s. K8s is a fairly common tool used on a few different managed providers to provide metrics. Remember how I mentioned that you needed a metric in order to determine how many pods you wanted to have or how many servers you needed? K8s is a metrics provider, which means that it creates some objects that allow you to listen to, for instance, the number of RabbitMQ jobs in a queue or something of that nature. And then scale your server space off of those things. So let's say that we were an attacker who really wants to do some damage. We can do like kubectl, kubeconfig, or yeah, kubeconfig. Okay. And we can say, okay, so because K8s is going to have permissions to change a lot of values on the cluster, that could be really useful to us. There's probably a lot of things that K8s can do that we want to be able to do. And then what we can do is we can basically do the same thing we did before, but instead of getting the secret from a deployment, because a service account is not actually something that you can just, service account secret is something you can just get. You have to create a token for a service account. We can create a token for the service account because that's something that a node would need to be able to do. So in this instance, we're going to be getting one of the pods, for instance, here, and then we're grabbing the metadata.uid, which is something that we're going to need in order to create the token for the K8s operator service account. So let's go ahead and do that. It's been a while since I created these. So this may or may not work. We pray to the demo gods. And we hope. So we're going to go ahead and we're going to specify the namespace with -n. And we're going to do PETA. And our pod name is going to be this KETA operator. And then we are getting the specific JSON path of spec.service account name. And we can see the service account name for it is KETA operator. Great. And now we can run another command in order to get the UID. I think that's just a little bit glitched.
You're missing an M in metadata at the end.
No, I think that's a
Okay.
text. I don't think that exists.
Oh.
Yeah, I'm not sure why that occurred. These things are a little bit glitchy with these fancy terminals sometimes.
Yep.
Okay, let's go back a second here. And I'm going to grab one more command real quick to create our service account token. And we're going to replace our UID here. By the way, this is all available online. There's a lot of documentation about this stuff. Nothing I'm showing here is a unique vulnerability that hasn't been released. This is all going to be. Wait, what happened to my UID? My UID is gone. That's so rude. Okay. We're gonna have to get the UID real quick. But there's a lot of nice documentation about this from Datadog. I highly recommend their stuff. We'll go ahead and do this. Okay, so it says failed to create token, service account, Ubuntu service account is forbidden. The UID in the bound object reference does not match the UID in the record. So that's because we've specified the wrong objects here. This is for if we wanted to create one for Ubuntu. Let's go ahead and do KETA. Great. Okay. So that time it worked, and we can see we got the token. Awesome. This is the JWT we mentioned earlier that's used to authenticate as a service account. Now we can use this in order to impersonate KETA. So we can go ahead and use another tool. This is actually a plugin for kubectl. We won't get into plugins either. They're really useful, but they're not default. This is something that can take in the token. You can actually just use this by default with kubectl, but you can't use kubectl whoami. And we can basically demonstrate with this that we have access to the KETA operator service account. And then we also can see the groups that we're in. There's another plugin that I'm going to show real quick here, which is called auth-cani. And this is really helpful because this is going to enumerate all of the things that I should be able to do. And so we can see a bunch of things here. We can list and watch service accounts and deployments. We can patch and update a few things. And then we also have star verbs for a few different resource types. We have scaled jobs and scaled objects. And scaled jobs and scaled objects, I won't get into this currently. Basically, the whole game is to try and create a job or try and create a container. Because if you can create your own container on the cluster, if you can define it, then you can also give it whatever attributes you want to give it. Which means that you can give it basically root on the node, which then gets you root access to that instance and out of the container. So because we have all verbs on jobs.batch. We can create batch jobs, which have container definitions. Scaled jobs and scaled objects also have container definitions. So we can use this in order to get a node breakout, or pod breakout. You can see here, this is the access matrix output. It's a different plugin that you can sort of use to get the same information. Jobs.batch, leases.coordination.k8s.io, and config maps. Config maps is also really useful because this means that we can edit the configuration for almost anything running on the cluster if it's in the config map. There's also a very important one that we use for EKS called the AWS auth config map. And remember how I mentioned earlier that the node endpoint was actually publicly accessible. This specific AWS auth config map is super important because it basically maps the IAM roles that have access to what specific users and what specific groups within Kubernetes. So in my example, there's this role IBS admin access, which I'm gaining access to the cluster through by default. But then also we can see that the nodes have access to the system bootstrapper group and the system nodes group through their own IAM role. So that's how they gain access to the cluster through these things to find the auth config map. And now because we have access to edit that auth config map, we can add ourselves in, even if we had our own AWS account. And then we could try and get creds for the cluster under system masters and gain root of the cluster, basically, just because this one thing was over permissioned. So last thing, can you use the node service account to backdoor pods? The answer is not really no. If you saw this and you saw, oh, well, we can create pods, that's creating a container. That means we can gain access to anything we want. Not actually. The Kubernetes team has done a lot of work to actually restrict access from nodes and basically stop you from doing these things. It's very, very fine-grained when it comes to nodes. If you go and you look at like the roles that nodes have, or the role bindings, it's not going to be explicitly parsable into something that you can understand because there's specific logic in the back end for node service accounts. So you can't actually update or patch these things, even though it might look like you can. But you can do a bunch of other fun stuff like we've demonstrated already. And it's not necessarily going to block you from gaining access to root on the cluster or the node that you're running on top of. So let's go back to these IAM roles, right? Like, how do we pivot out of the node? Sure, we've gotten access to the node. That's just a server though, right? Like now we can get access to the stuff inside the pods. Maybe we have access to all this stuff running inside the applications. That's really good. What about the AWS account itself? And how do those things work? So there's something called IRSA, which is a little bit complicated. You don't need to understand this diagram. All that you really need to understand is that there is sort of a authenticator called an OIDC provider, and STS, which is a internal AWS service which manages like identities, trusts the identity provider, and the identity provider can verify that things coming out of your cluster were signed correctly. So then you can create sort of mappings for service accounts to have a role, and because the service account has a way to prove its identity, then that service account can prove its identity to the provider, and the provider is trusted by SDS, so we can then gain access to whatever IAM role is specified within that provider. Time check, Sam, how are we doing?
Well, we don't have a particular cutoff time. I'd try and end by 7:30 though.
Okay, got it. I think we can do that. So this is the really important part. The IAM roles themselves. Because we have access to all these other service accounts, and the service accounts are the things that contain the IAM role or the creds for the IAM role. That means that theoretically, we can then also go and we can steal those service accounts. Or sorry, not the service accounts, the IAM roles attached to the service accounts, which are going to have a variety of permissions over the entire account, like I said. So we're going to go into this demo in a moment, but first I want to talk about what this means. We have a lot of other policies. Like, remember we were looking at these earlier that were sort of poorly scoped. They're accessible for a resource star that allowed us to get all of the instances in the account. because Kubernetes doesn't know about any of these things by default, it's not made by Amazon, it's not made by, well, it is made by Google, kind of, but it's not specific to GKE. It's not tied into those things by itself. It needs plugins or operators in order to function. And those things need to have permissions over the AWS account or the GKE, right? Which means that those things are also running on your cluster, and those things are also service accounts. So if you want to have something that can assign a disk to a pod, anything beyond the default configuration for what your node has on it, like the disk that comes attached with your instance, you're going to need an EBS plugin. And an EBS is going to basically provide the resources that you ask for to attach to your containers. And so it needs the ability to attach volumes. It needs the ability to modify volumes and also to create volumes and create snapshots. And these are all poorly configured by default. So you can go in and you can now create snapshots and attach volumes and move them around however you like, meaning that you can modify volumes and you can detach them from one instance and you can attach it to your own instance to then read data that maybe some other server was trying to access, which is quite rude to the other server and probably will cause an outage. But it's great for you. And we can do a lot of other fun stuff as well, like the cluster autoscaler policy. This is important because, like I said, we need to be able to scale up. We need to be able to have multiple nodes. And we can't scale up if we can't change the autoscaling information. So, of course, the cluster autoscaler runs on top of the same node that we are, and it can change the numbers. So now we can change the numbers, and we can say, I want it to be 1,000 nodes, and you can really run up somebody's AWS bill, or you could change it down to 0, and you could turn the entire cluster off. And the really great thing about this is that once you've turned the cluster off, once you've scaled down to 0, guess what? The cluster autoscaler was running on that node. So it's not going to restart. It's just going to stay at 0, unless they have some other thing to protect it from happening. And then there are a few different things. There's actually a condition on this, which does stop you from doing this to other clusters. It can only be your own cluster, but I would still say that's bad enough. I don't think that you're going to see a lot of clusters anyway. It should probably be one cluster with a lot of namespaces and configurations or node groups. Cool. So next thing is external DNS. You can pretty much deploy any regular thing that you might expect to have in an environment from Kubernetes object definitions. And that includes resource record sets, or basically DNS records. So most people will install this external DNS provider, and that has the ability to read all of the hosted zones, all of the internal domains within that account, and also change the resource record sets, which basically means that we can now create domains or change the thing that a domain is pointing to for that account. Again, resource star, the whole account. I think the worst thing, in my opinion, though, has to be Carpenter. Carpenter is a plugin that sort of replaces the cluster autoscaler because autoscaling groups in AWS are sort of dumb. They're just like, how many of a thing do you want? Carpenter is a little bit smarter than that. It tries to sort of optimize, right? Like you might have, 10 instances that are all running a very low amount of CPU and RAM because there's some like port that it needs open or something like that. And it's very inefficient, right? Then you're wasting a lot of money on compute that you're not using. What Carpenter does is it tries to optimize the actual EC2 instances that you're using, the actual amount of resources that you need based off of the running containers. And a few other things as well. But basically, if you need to be able to create new things, you're not just changing a number that's managed by some other service. That means that you also need to be able to pass in the node IAM role or potentially other IAM roles. And you need a thing called pass role for that. Pass role allows you to pass a role to an EC2 instance. And there's a few things about this, right? But they actually threat mod for this, because what this means is that you can then pass some other role in the account to a new instance that you've created. So you can choose any role in the account and then pass that role, which has its own permissions, to something that you own, and now you have those permissions. And specifically, pass role will define a list of roles that you can access, usually, And Carpenter has mitigated this. They said, okay, only by default, we're going to include the EC2 node class role, which is something you really need, right? Nobody would ever do more than that, unless you really need to. But how are people deploying this? Well, people aren't really looking at these deployment configurations. They haven't seen these poor defaults, right? So Carpenter, when you deploy it with Terraform, and this is, by the way, the official EKS Carpenter IAM role chart thing that you have to deploy, we'll just use a default of star, which means that even though Carpenter threat modeled for this and defaulted it to a safe default, Terraform overwrites this with the value star, which means that you can use any role in the account.
Great.
Cool. Moving on, let's go ahead and should we do a demo of this, Sam, or should we move on?
Well, I don't know, whatever you think.
I think I will leave this as an exercise to the reader. The code is here. It's not very hard to do. You just need to be able to know how to do it. Again, reference like Datadog sheets. But we're going to cut this for brevity right now. Cool. So actually, one more point I wanted to make. All of these things that I see here, these are all publicly available, right? So if you get onto a cluster, most of the components running on that cluster are probably not going to be things that are written by those specific developers. So there's no need to enumerate them. Even if you don't have permissions to go ahead and read all the IAM policies or roles in the account, that doesn't really matter as long as you know which ones there are, and then you can look up the policies that go with those things. So you don't need to enumerate them at all. You can just look on GitHub and you can read the policies. Cool. So there's so many things to attack in Kubernetes. It's unreal. I think by default, they still have this where anonymous access to kubelet is enabled. This is the service that runs on top of the nodes. And this is really great because this means that if you have network access, let's say you've gained access to a pod and you've got a shell, you can then access the API for a kubelet and then use this to gain access to other nodes through this. In EKS, this is disabled by default. I don't know if that's true on other cloud providers. This is from the configuration of EKS right here. It's disabled by default. But on vanilla Kubernetes, it is still enabled by default to my knowledge. So you can go ahead and you can access those things and you can get RCE on any other node that way. The next thing is you can also do a lot of other network attacks, which are really interesting. You can do DNS poisoning. You can do ARP spoofing. And that's because at the end of the day, it is just a container running on a server. And by default, you have a lot of capabilities. This is a list of capabilities. This is sort of like a low-level Linux thing that determines what a process or specifically a container here is capable of doing within the system without being root or even with root. You can sort of limit these things. But because we have the ability to just send packets, normally we can open raw sockets. That's a difference by default. Normally you need root in order to open raw sockets on Linux, to my knowledge. I'm not certain about that. But we can do ARP spoofing here. And it's just like the old days where you would go into an internet cafe and you would poison the ARP traffic, and then you would be able to get everyone's traffic running over you. For anything running on the same node, you can just ARP spoof, and then you can send all of those pods traffic to you, and you can man the middle of that traffic, modify it, read it, do whatever you want, and then send it on. And if you're running on the same instance as core DNS, for instance, that means that you can then intercept all of the traffic that should go to the DNS server. And that means that you can now intercept traffic from other nodes or anything that's going out to the internet, which will, by the way, first hit the internal core DNS server. You can now intercept all of the internet traffic just because you gained access to one of the pods and it had this net raw capability by default. Now, one more thing I want to demo is Kubehound. Kubehound is really cool. There's a lot of cool Kubernetes security tools. And I don't think that we'll come back to this. We can see if we can come back to it. But it's a graph database basically that allows you to ingest data about the cluster, and then just basically look for all of the container escapes based off the relationships of different objects, and you can visualize those things. KubeHound also has really great reference material for like breaking out of containers and other things that you can do within the Kubernetes environment. The one downfall of this is it's not aware of any sort of like bootstrap tricks or any cloud provider specific issues. And that is going to be an issue that you encounter a lot. The environment that you're in is going to be very different, even though it might be Kubernetes in one place and Kubernetes in another place. It's going to be very different based off of the plugins that are installed on that cluster and like how it works, what are the operators, and then also what provider is it running on top of. And a lot of tools don't well support attacks on different cloud providers. But here's a couple other ones that I liked. Kdigger is super helpful for like local pod enumeration and breakout checks. Alpine Container Tools is like a little container that you can run to play around with stuff. It's very good for really diving deep. And K8s, I'm not sure how to pronounce that, is like a red team focused pivoting tool, which can do a lot of attacks automatically. There's a bunch of really cool stuff. Again, KubeGoat has a lot of cool tools linked there as well in the scenarios. Highly recommend you go read that. So final thoughts, things you should take away from this is that Kubernetes is like really complex, but it doesn't have to be. And a lot of the old tricks still work. You have to really think about like, how does this thing work? Why does it work? And then how have people properly defended against it? Or like, how is it configured? And are people actually aware of all the things they're installing? In most cases, the answer is no. Remember how earlier we looked at the Helm charts? And the Helm charts were like, you could just Helm install Grafana or Helm install GitLab. It's super easy to deploy things without really understanding them or configuring them properly. And I think that's the most common issue that you're going to see. Things are not configured correctly. They're configured insecurely by default. And they all have things that they need in order to function. So if you are not specifically, if your cluster isn't hardened, you're going to be in a really good spot as an attacker just because there's so many additional things that you have access to. The environment is so much more complex. There's so much more attack surface. So all the normal cloud stuff still applies, like all the normal networking stuff still applies. Try to abuse bootstrapping and the specific cloud provider that you're on. And another really fun thing is that because of these node privileges and how they're in relation to the node that you're on, increasing load is going to increase the autoscaler, which also means it's going to deploy more of the application that you're on. So then you can potentially get yourself scheduled onto another node that has the thing that you're looking to attack on it. So just by like sending more requests and like almost DOSing an instance or an application, you can actually extend your access, which is really fun, I think. So last thing is are all these things fixable? Absolutely, they are. There's a lot of information out there about fixing these things and making it secure. But I think it's really hard because things are so insecure by default, right? Like you have to go in and you have to change these things. You have to make sure that you're using IMDS-v2 and that you're setting the hop count to 1. You can't actually reduce that on IMDS-v1. It's not a thing that you can do. So a lot of older providers that have applications that require IMDS-v1, they just can't change this without refactoring their application. And that's why a lot of people are still on this. So it's insanely easy to gain access to this in many cases. Also, you can go in and you can fix the roles yourselves. Like you can specify the role that each thing is going to have, and then you can just change the tags on it. You can give it a condition. You can say, hey, make it only apply to this cluster, and or make it only apply to these record sets or something like that. And you can do the hardening yourself. There's nothing stopping you from doing that. Lastly, you can actually move some of the default permissions that things need into their own roles, which you won't have access to by default over the node role. Specifically, the VPC CNI role, which is by default the thing that allows you to attach a network interface to anything else in the account. You can separate that out and you can fix that so that you would at least have to get sort of like a host privilege access in order to gain that access. Lastly, you can do pod security standards. Pod security standards aren't as good as pod security policies, which they used to have, in my opinion. But the pod security standards are really good because it allows you to enforce rules basically for each of the pod deployments, and basically prevents you from, or anyone on the cluster, from putting out something that like has a lot of these capabilities that are bad by default, or mounting root directories or something dangerous like that. And these are really helpful. Highly recommend doing these on your cluster. Here's an example. The pod security standards are not as good, like I said. It's kind of annoying, specifically because you have to create them and you have to specify a namespace that they apply to. And you can apply them to all namespaces, for example, here. But that isn't going to make it all namespaces forever. If you make a new namespace after that, that new namespace won't actually have the pod security policy applied to it. So another thing to know about that. But I think this is a really missed opportunity for a lot of vendors and just devs out there, because container security can make it really, really, really hard for me to do anything as an attacker. There are so many things that you can stop me from doing that I could absolutely do on a regular server that I can't do in a container if configured properly. Like there are O-days that will give you, privilege escalation that user namespaces will stop from working at all. So you are mitigated against O-days before they even come out. And in many cases, depending on the primitives those O-days work off of. You can do read-only file systems, so I can't even download any tools. I have to work with what's there, and like there's nothing on that to begin with. If my attack relies on writing a PHP script to your web server, I can't do that anymore because the file system is read-only, right? Not a thing that I can do. And you can just also like achieve the dream of traffic control and visibility. For a lot of places, they can't actually really stop an attacker from exfiltrating data because there are so many ways that you can do it, and it's hard to detect. And you can't really profile what an application's network is usage is going to be because it's running on a host with a bunch of other stuff. And it's very messy. So there's a lot of like AI products out there that exist in order to try and solve the messiness of the traffic control and visibility problem. I'm like profiling. But with a container, if you just open up TCP dump on a container, you're going to see nothing because there is nothing running. It's empty. Whereas on a regular host, you're going to see so much traffic going from ARP traffic to like HTTP traffic from services running in the background. There's endless amounts of traffic. Doesn't exist in containers. You can create mesh nets. You can do a lot of blocking there and profiling, and you can know exactly what your application should be doing and what it shouldn't be doing, and detect attackers really, really easily. Also, the fact that these are pods and they scale down and scale up, and you can also just give them specific runtimes, like means that I'm going to get kicked off a server every 3 minutes or something. It's going to make my life really, really hard as a red team operator. So thank you, everyone. I hope you enjoyed the talk. I hope you learned something. I hope it wasn't too complex. But I hope that you come away with it with like at least one thing and sort of understanding of like what Kubernetes is, and maybe a general idea of like what things you should look for when you're attacking servers, and what mistakes defenders are going to make. I think a lot of these things are apply to a lot of areas of security, specifically the configuration aspects and the defaults. It's good things to look out for, and really trying to like understand exactly what's happening under all of the magic is what's going to get you the best attacks and understanding of like how to hack something. So thank you. I hope you enjoyed the talk.
Thanks, Kaz. That's really good. I'm very happy to see that you can run KubeGoat locally. I think I can write projects for my students using that. They don't have to. It doesn't have to be on Amazon or anything.
Yeah, they designed it very much that way. I would still encourage people to learn on EKS or GKE because that's more likely what you're going to see in real life. But you can do a lot off of just like locally as well. So
yeah. And there's a question in the Twitch. The techniques you showed assumes we have access to the cluster. Does it imply the external attackers need to gain access first?
Yes, because like I showed earlier in the application isn't any different just because it's running on Kubernetes, right? Hacking Kubernetes from externally or initial access is not going to change at all from your typical stuff. You are still going to need to find initial access through some AppSec vuln or something of the nature. So that is,
Yeah, and Zoom is open right now. You can come join. Let me stop the recording. Figure out where I put the recording right here.